In this video, I am going to explain about the ARP operation in SD-Access. You know that ARP or Address Resolution Protocol is a protocol that we use it in IPv4 environment for finding the MAC address of receiver. And here in the left figure, you can see ARP operation in traditional network. As you know here, as you can see here, host 1 needs to find the MAC address of host 2. It will send, as you know, the ARP request. This is a broadcast message, and to find the MAC address for the IP address 192.168.0.10. As you can see, this is broadcast, and only the receiver or the intended receiver will answer with this ARP reply message. This is unicast. As you can see, my MAC is this MAC, and after that host 1 can send traffic to the host 2. Actually, the SD-Access fabric provides many optimizations to improve unicast traffic flow and to reduce the unnecessary flooding of data. One of the first optimizations is ARP suppression. While traditional ARP flooding means broadcasting is workable with the smaller scale subnets deployed in a traditional enterprise network, this would be very wasteful of bandwidth in larger networks. In an SD-Access deployment, this is fully addressed. Here you can see ARP in SD-Access fabric, and I will explain about all of these steps. Within SD-Access, Anycast gateway are populated on all fabric edge nodes. It means that in S1 means fabric edge node 1, and here S2 fabric edge 2, we have the same IP address as the gateway. For example, the gateway of a specific VLAN has IP1 in this switch, in this fabric edge node, and we have the same gateway IP address in the switch 2. This is Anycast gateway. The endpoints means C1 and C2 in these subnets could reside anywhere in the fabric or even roam between edge nodes. ARP operation in SD-Access has been designed to improve the efficiency of this process in a fabric deployment. In this figure, as you can see, a wired client C1 is connected to a switch port of the edge device S1. It has already obtained an IP address from DHCP, and you learn about the DHCP operation in previous video. Actually, you know that how this C1 has IP address. But the client wants to communicate to an other client, means C2 connected in the same subnet, okay, on a different edge node, means S2, okay. Actually, we are talking about the intra-network communication. You know that we have two types of communication. Intra-network means direct communication, and inter-network means between two subnets to networks, for example, with the help of default gateway or IP address. All right, let me to explain about these steps. Step 1, here, as you know, we have gateway, we have switch 1, a fabric edge node 1 and fabric edge node 2. Here we have control plane node, here we have border actually node, and this is the fabric enabled wireless LAN controller. Okay, let me to start with step 1. Step 1, to start communication to client C2, client C1 sends out an ARP request to discover the MAC address corresponding with the IP address of client C2, and you know that the C1 doesn't know about SDA fabric. Because of that, this is exactly same as the ARP in traditional network. ARP request, okay? Edge node S1, okay, process this ARP request. First, S1 registers the client C1 to the control plane. As you can see, inside of ARP request, we send, the computer 1 will send the MAC1, let me to write here, okay, its IP address, its MAC address, okay, and because of that, the ARP request include this IP address, and also the target IP is the IP address of the receiver or IP2, but we don't have the target MAC. Okay, we try to find the target MAC. Okay, because of that, when we send this information in the ARP request, then here the first function of C1 is registering the client C1 to the control plane. And you know that in control plane, we have a mapping table. Okay, this is a map server, or actually MS. Here we have, from this RLOOK means the RLOOK of switch 1. Let me write here RLOOK switch 1. Now we have access to the IP1 and maybe MAC 1. Okay, means the MAC of computer 1. This is the same as first step. And then S1 floods the ARP request out the local ports in the same VLAN as the client that sent the ARP request. You know that here we need to consider some important features. Look at here. Assume that this is our switch. And our switch has multiple interfaces. Okay, one interface connected, okay, to the SDA fabric. Actually, this is the fabric edge node, okay, and because of that, at least one interface of this switch is configured as switch port and IP address, and after that connected to SDA fabric, and it's okay. But you know that in the switch one, in S1, we can have multiple interfaces. Okay, they are connected to the computers, or actually the endpoints. For example, this is the PC1 and this is the PC2. All of them are members of one VLAN or same VLAN. Okay, what does it mean? When you send ARP request from PC1, this is broadcast. As I mentioned before, the PC1 doesn't know anything about the actually SDA. Because of that, when we receive broadcast, means the destination MAC of quad F, quad F, quad F, okay, the S1, okay, yes, it should register the information of PC1 in the mapping server. It's okay, in the control plane node, but it also should flood, like traditional networks, this broadcast message to the ports of this switch in the same VLAN, okay? This is the local behavior. Because of that, we will have this message broadcast here and also here. It is easy to understand. Don't forget, here we have SDA fabric, but here we have traditional actually switching network. Because of that, S1 floods the ARP request out the local ports in the same VLAN as the client and that sent the ARP request. And also, S1 also sends a query here. This is important. S1 also sends a query to the control plane node to check if it has the MAC address corresponding to the IP address of the C2. And here you can see it. Do you have the MAC address of C2 and where? It means that please give me the MAC address of C2 and also please inform me about the RLOOK of that MAC address, means the connected, for example, switch 2. Okay, here in the mapping table we have IP1, MAC1, okay? And maybe it is possible that a control plane node has the information of the C2. And this is the step 2. And also, here we have different conditions. The control plane has the entry for C2's MAC address, okay, and IP address, and returns the MAC addresses information to S1. Along with the MAC address, the control plane also returns client C2's location, means it is behind of S2, means RLOOK. Because of that, now S1 has the MAC address of C2, and also it knows that the MAC address C2 is behind of the RLOOK of actually switch 2, okay? Because of that, S1 caches this information to suppress subsequent queries for this client. And then S1 then replaces the broadcast address in the ARP request with the MAC address of client C2. As you can see, step 1, and all of them are step 2. Step 2, first here, the local actually ports, and then step 2, and receiving the information. And now in step 3, S1 can encapsulate the ARP request in unicast VXLAN, okay, and making the broadcast ARP packet to a directed unicast with the destination of S2. Why? Because we received the RLOOK address of the S2. okay? And S1 applies the appropriate policy context like a virtual network and SGT scalable group tag and transmits the VXLAN frame to S2. This is the step 3. And in step 4, S2, okay, de-encapsulate the VXLAN header from the incoming packet and knows that the packet is destined for C2, and S2 then forward the ARP request to C2. Client C2 examines the incoming ARP packet, then respond with its MAC address in an ARP reply packet. S2 accept the incoming ARP reply packet, encapsulate in VXLAN toward S1 and forward it to the S1. And finally, S1 decapsulates the VXLAN header and forward the ARP reply packet to C1. And this is completing the ARP discovery process. All right, now let me to explain a little more, one more time, about the intra-subnet traffic in the fabric. Actually, we review the process that we learned, but now with a little more detail. Actually, if you want to learn everything correctly, you need to have a high-level knowledge about it, and after that, step by step, you can deep your knowledge. As you can see here, we have this network, 2 fabric edge node, fabric edge A and B, and also 1 control plane node, and 2 endpoint A and endpoint B, and you can see the IP addresses of the endpoints and also the RLOOK IP address that we have in each switch. And here we have the control plane node. Okay, as you can see, if the destination endpoint is in the Cisco SD-Access fabric and in the same subnet as the source endpoint, it means we have intra-subnet traffic. Okay, and here we have these steps. Step 1, the source endpoint A sends an ARP request for the MAC address of the destination endpoint B. I explained it, okay? Step 2, the list process on the fabric edge node A or endpoint A's fabric edge, okay, intercept this ARP request and ask the fabric control plane for the requested mapping of endpoint B's IP address or to its MAC addresses, okay? And here you can see we have the request from the control plane. And you know that also it will register, I explained it, the registers the information of host A into the control plane. Okay, because of that here we have 100.100.027 and this is the MAC address. Also, we assume that the control plane has the MAC address of the endpoint B. And after that, this is the step 2. The fabric control plane looks up endpoint B's IP address in its Lisp address resolution table. This table is similar to a switch ARP table, as you can see, but is specific to Lisp. The fabric control plane then sends this MAC address to fabric edge A with the Lisp ARP reply message, means encapsulated ARP reply message. It's okay. And in this figure shows endpoint A sending an ARP request for the MAC address of 100.100.022 to fabric switch A. Okay, if fabric switch A intercepts the ARP request and sends a Lisp ARP request, okay, means the encapsulated ARP request to the fabric control plane, and the fabric control plane replies with an entry from its Lisp ARP table. Now, fabric edge A stores this mapping in its local ARP cache and then queries the fabric control plane again for the location of endpoint's MAC address. Yes, we know it. And after that, the fabric control plane here, you can see this process. We have the map request for this MAC address. You know that this MAC address B9A is the MAC address of the host B. Okay, actually, the fabric edge A will ask from the control plane what is the RLOOK for this map request. Okay, and it means that the fabric control plane responds with the RLOOK address of fabric edge B map reply and means this is the RLOOK of this MAC address. The RLOOK is IP address of the RLOOK of the fabric HB 100.128.120 actually 48.120.35. And it means that the fabric HA now has this information: the MAC address of the endpoint B, and also the RLOOK that we can reach to that MAC address. The important note here is all subsequent traffic between endpoint A and endpoint B is sent in the same fashion, encapsulated in VXLAN and sent directly between fabric edge A's and fabric edge B's VTEP or RLOOK addresses. Also, about the inter-subnet traffic in the fabric means the two hosts are residing in two different subnets. Actually, the source endpoint A, this endpoint, sends the traffic to its default gateway, which is the Anycast gateway configured on an SVI on endpoint A's fabric edge. Here we have the SVI interface. Okay, fabric edge A queries the fabric control plane for the location of the IP address of the destination endpoint B, as you can see, map request, and the fabric control plane performs a lookup and forwards the message to endpoints B, okay, and it means to the fabric edge of endpoint B, and then fabric edge B responds to fabric edge A with its RLOOK address. And after that, this figure actually shows fabric edge A sending a list map request for endpoint B's IP address 100.101.0.22 to the fabric control plane, which forward it to fabric edge B after a lookup in its table. Why? Because the control plane knows that this IP address 100.101.0.22 is reachable from this RLOOK. Because of that, it will forward this map request. This is the default behavior of Lisp. I explained it before. And then this is the fabric edge B, not the control plane, answer the RLOOK of destination, RLOOK of actually this switch to the fabric edge A. And it means that if you want to send traffic to this IP address 100.101.0.22, you can encapsulate it to me, to actually fabric edge node B, okay? And then fabric edge A installs the mapping in its map cache table, encapsulating any traffic to endpoint B's in VXLAN with fabric edge B's VTEP or RLOOK as a destination, and forward the traffic through the underlay. Return traffic is processed in the same way, and all subsequent traffic between endpoint A and endpoint B is now encapsulated in VXLAN and forwarded through the underlay directly between fabric edge A and fabric edge B. And finally, for traffic to destination outside of the fabric, you know that any traffic that is destined outside of the fabric will be processed first. The source endpoint means the, for example, endpoint A. Okay, this is the endpoint A. It should sends the traffic to its default gateway, which is the Anycast gateway configured as an SVI on fabric edge A. Okay, this is the fabric edge A, and here we have on each of them we have the same SVI. Okay, SVI here, same SVI here. Okay, this is the Anycast gateway IP address. And then fabric edge, for example, this fabric edge A checks its list map cache to find a match for the destination endpoint B. If there is no match, because this is outside of the network, it sends a list map request to the fabric control plane again. For example, this control plane. And the fabric control plane checks its Lisp EID table for the IP address of the destination, and if there is no match, returns a forward natively message to fabric edge. Okay, I'm not going to explain about the detail of it now, but here, let me write here, forward natively. What does it mean? It means that you shouldn't actually encapsulate it to other, for example, fabric edge. You need to forward it natively. And what does it mean? It means that fabric edge A, this switch, encapsulate the packet in VXLAN with the destination VTEP or RLOOK of the fabric border. It means that the traffic will forward it to the, will encapsulate it to the border node, okay? And actually, you know that the border node is configured as proxy egress tunnel router, or PTR. And return traffic via the fabric border is processed in the same way as traffic within the fabric is processed. It's so easy. You send the traffic to this switch, to the fabric edge node, and actually, because this is your gateway, it asks from the control plane. Control plane says that we don't have this EID, this actual destination IP in our SDA. Send it to the border node. And because of that, the edge node encapsulated to the border node forward it natively to the outside of the network. So easy. And when the answer received, again, we have similar process. The answer received for one specific actually edge node or endpoint, and it can, the border node can ask from the control plane node inform it about the RLOOK of fabric edge node, and finally the border node can encapsulate it to the actually destination fabric edge node. Okay, actually here we have some details. The details are not important, but now we learned about the ARP operation and the process in 3 different conditions. You know that the first and 2 are important for us. They are related to the SDA fabric, means intra-subnet traffic and also inter-subnet traffic. But the last, traffic to destination outside of the fabric, is so similar to the inter-site. Okay, the only difference, inter-subnet actually, the only difference is that you don't send it to the, don't send the traffic to the actually destination or receiver fabric edge node. You send it to the control plane node. And now we have more information about the process in the actually SDA fabric, about the ARP operation. In previous video we learned about the DHCP. Now we know about the ARP operation. And don't forget, and I think you can easily understand that if you want to understand all of these functions, you need to know about the Lisp and also VXLAN, as we learned about them up to the level of this course in the first videos of Cisco SD-Access Foundation. And you can see now they can help you to understand these details of Cisco SDA fabric. Actually, in the background, this is the LISP or Lisp and VXLAN work with each other, and finally we have the option of Cisco SDA fabric. And you know that when we configure something from the Cisco DNA Center in future, actually we modify something in the underlay about the Lisp, in the overlay about the VXLAN.